Hello everyone, I hope you can hear us. I am Harish Kulkarni and I am here with Vinesh.
Hello everyone.
Both of us represent Altizon, a pioneering industrial IoT platform company. This will be about a 20-25 minute session, out of which we'll have the last 5 minutes for Q&A. But if you have any questions anytime in between, feel free to type in your questions using the questions window and we'll answer them. I understand most of us on the session today are always looking out for ways and means to improve productivity and quality, which means we believe there is always a scope for improvement. We all look at data to take decisions, but most of these are based on either on derived data or perceived data. Having worked with 130 plus enterprises across the globe, our study has revealed that almost 86% of all plant floors across the globe have some kind of production management system in place. However, an alarming 78% of those still have some kind of manual data entry at various points in their production process. So we can draw some important inferences from this research. One, this data is not real time, hence there is no real-time situational awareness, and as a result of which the analysis is post-mortem analysis, which has very little impact on controlling the losses that have already occurred. Second, manual data entry can be error-prone, which lacks transparency and can also be a resource-intensive and time-consuming activity. Third, it lacks single source of truth for data analysis, and as a result, implementation of improvement initiatives can extend over a longer period of time, further delaying the expected outcomes. Fourth, without this, the real-time situational awareness, we cannot act on the problem that we want to solve, and this leads to further increases in unplanned downtime, leading to a low yield. This lack of visibility can lead to setting of production targets on the basis of perceived capacity or perceived OE, which can further lead to underutilization of assets and resources. It is possible to have visibility into every step of the manufacturing process, and a truly connected production line has data points throughout the line, and together they create an extraordinary volume of information about downtime pockets, contact time losses, and reveal the hidden capacity of the line. This data-driven uncovering of gaps in the production, or as we say it is the hidden factory, can actually drive actions for immediate improvements in throughput and quality. To thrive in this new data-rich era, manufacturers need to establish connectivity of assets for improved real-time data mining from the plant floor. And with this real-time data and analytics in place, manufacturers can make faster and better decisions based on real-time information rather than assumptions or prior experience. I'd like to share an example of a highly TPM-oriented company which used to have a consistent average OE around 80%, and they wanted to further improve their line by implementing IoT technology. When we connected the line, to everyone's surprise, the actual OE shown was an average of 45% as against the originally reported 80%. With the availability of real-time time-stamped information, they could actually and easily uncover the hidden capacity by understanding the reasons for erroneous OE numbers. The most common reasons were their standard cycle times were either inflated or set based on negotiations with workers and had a lot of inbuilt buffers. The contact time losses were very high and the line had many downtime pockets. This real-time visibility enabled immediate action to overcome these low-hanging issues. We noticed that their continuous improvement initiatives were not delivering substantial gains as the benchmarking was done using the perceived data and not the real-time data. Once they had the real-time data coming in, they could not only monitor status but also analyze that data to understand patterns and use machine learning algorithms to go to the root cause of the problems, to predict as well as eliminate those problems. This data brought in transparency, leading them to take data-driven proactive actions to minimize failures and also corrective actions for process improvements, making their lean initiatives more effective. This improved visibility combined with alerts and notifications also help them quickly identify the right set of people required to solve problems, making their Gemba Kaizen initiatives more fruitful. So this was a brief overview of how you can uncover your hidden factory, uncover the hidden capacity, and actually unlock that potential to gain improvements, substantial improvements in productivity. I'd like to now transfer to Viresh, who will walk us through the roadmap for Industry 4.0 to actually uncover this hidden factory and also discuss a few use cases. Viresh?
Sure. Thank you, Harish. I just looked at the comment from one of our attendees mentioning that the audio quality is a bit poor. So I hope it is now fine and you are able to hear us okay. So let's talk about how the IoT is implemented within the manufacturing organizations. So what we have done is, we have categorized these three aspects as no automation, semi-automation, and full automation. We'll dig deeper into that. But if I could summarize what are we talking about over here, that would be dirtying your hands. That's very important when it comes to IoT implementation. So it is imperative that we connect to devices or machines, which is a tough task at the end of the day. And once we do that, the another task that we have on our plate is how do we analyze that data and how do we make meaning of that data, and after that how we can create value on these particular data sets. So let's walk through each and in each of these scenarios. Let's take a no automation scenario. So we might have come across plants which are old plants which have been there for a longer period of time, where their progress has been in a phased manner. So always the first unit would always be a manual kind of a process, and then gradually they might have, over a part of their growth, they might have implemented the automation. So one scenario is where you have old legacy machines which are not really smart, and that's one more challenge. Then the second aspect is where you have automation, but it is sort of bits and pieces. So if one could take an example, if one can consider a forging line, for example, it consists of anywhere from 7 machines to 17 machines based on the kind of process that we are going through, right from cutting to induction furnace and pick and place the robots and machines, as well as the pressing machines and so on, until the quality. So you could see that there are machines which are totally automated, like a press machine, like a robo, but there are machines like, once you look at cutting process, for example, they really are not that smart. And once you look at the quality process, where it is more of a manual intervention. So this is a scenario that we would call it as a semi-automation, where less amount of automation and a combination of both automation and semi-automation. And the third scenario, we see that we have seen customers boosting us, saying that our plant is fully automated, where we are talking about many PLCs installed on the machines. The second scenario is you have 5 different processes in one plant and with 5 different SCADA systems. And the irony over here is, once you have the full automation, they actually don't really talk to each other. In some scenarios, yes, we agree that they talk to each other, but there will be something called as a main PLC or a main SCADA. So this main PLC or a main SCADA would connect with each machine or each line for very specific tasks, which are the objective would be for monitoring and controlling purpose only. So with these scenarios, we enter into these factories and then try to connect with them and get this data aggregated at one particular place, so that wherever the chief executive officers are, or the ground staff who consist of maintenance managers or production managers, engineers, and so on, they would be getting all this information at one particular place, and which becomes a transparent kind of organization where everyone is on the same page. I'll move to the next slide. Now, this is a part, how we end up connecting and create value. So let's look at all these three scenarios. No automation, semi-automation, and fully automation. They come with different flavors. So if I could take no automation, you are looking at a legacy machine which is 20 years plus, and which may have sometimes it may have control systems, but those control systems are not supported by the OEM right now, and they might have retired those control systems. And in many cases, we have come across older machines which are having protocols like DH+, and right now these are not being used. Primarily now, the most of the machines that are new generation, they are Ethernet enabled. And some machines which are manual and absolutely don't have any smartness to get connected over here. So we look at these machines, we evaluate these machines, and look at different approaches how we can collect the data. In case of a legacy machine where the hardware kits come into picture, here we would go to the customer's premises, do the feasibility analysis, come back with the main parameters that are required to monitor the OEE, productivity, or condition-based monitoring. Also, the hardware scenario comes in when you are building a bespoke kind of a kit to do remote asset monitoring. So, for example, it can be an excavator where it is functioning at different levels, or it can be a pump or a compressor which is running at a customer locations. There, either you could end up building the hardware or utilize a hardware which is already available in the market. The second scenario is best case scenario where we look at is a PLC or a SCADA kind of a scenario. So we would end up connecting these PLCs and SCADA systems or through the controller and bring the data at one particular aggregator. And in some cases where we have seen that if I could take an example of a steel plant, you have 5 to 8 different kind of processes, and in these processes you have different historians functioning at different level. And if one could look at entire plant, they absolutely don't talk to each other. And the problem that everyone has over here is people don't have all the things on the board with respect to one dashboard. So with these three scenarios, we look at aggregating the data into industry standards, be it OPC or be it an MT Connect. So we have devised our IP, which we call as gateways, which is nothing but a firmware or an embedded software which sits next to an OPC or an MT Connect, or it seamlessly gets installed into the microcontroller of the hardware and then push the data securely to our Datonis platform. And so Datonis is the cloud-based industrial Internet of Things platform, which primarily does the heavy lifting of the data with respect to securely collecting, storing and processing and creating analytics on top of it. And apart from that, you have the ability to create a lot of alerts and notifications on the Datonis platform, plus the ability of having predictive through the machine learning algorithms. So once the data is massaged and processed, it becomes very easy to build applications on top of it. So here on the application layer, we have something as an offering which we call it as iProd. iProd also comes in different flavors. So primarily, if one could look at how Datonis and iProd is being used, Datonis primarily would be a one-time kind of a configuration and utilized by administrators who come with a minimum software development experience or a software administration experience, so that they can manage the devices and create the devices, configure the systems, etc. Primarily the application layer, which is iProd, which is used by the business users, which makes sense for them on knowing what's happening in their factory. As a next step, I would like to take a very specific use case where we are talking about success stories. This use case is of a large India-based automotive OEM, so or rather automotive component company. So this particular company, we engaged with them 2.5 years ago, and they gave us a plant, a specific line where they had a challenge of monitoring OEE and connecting this particular production aspects with the manual testing facility that they had. And the other challenge was they gave us some sort of pick and place machine where the controller per se was locked by the OEMs. So the easiest step is that you go ahead and then ask the customer to get in touch with your OEM and make us the data available. But in this case, it was not possible because the OEM was not able to support them. So we took up this challenge, took up minimum amount of data, which was very important for them, and connected these machines. And apart from that, we also thought through the process of their testing, and we also automated their testing process. The customer was happy, and immediately we were given one more challenge. They had this TPM award that they had won through Japanese Institute in 2014, and they asked us, this particular unit is well versed with, they have excellent processes, and if we can show some improvement over here, that would be a great deal. So we could took that challenge as well. They had 3 different lines, a grinding line, a pressing line, and a forging line. We took this particular challenge and we executed the IoT over there. And this particular initiative, which was more or less focused on the productivity and the condition-based monitoring, extended into a project where they wanted to integrate the data coming directly from the machines into their line of business applications. So the integration was done with their LOB application, which was SAP there, and SAP punched in the data from the we pulled the data from the SAP with respect to the planning and pushed the data of the production data into the SAP. So in a nutshell, they got the real-time information of for comparing what was planned versus what is actual, apart from getting other benefits with respect to OEE and productivity. And we also, after that, we were given 6 different units in different geographies. And in my last slide, which showed that one of their executives announced in Machinist magazine that they are working with us to integrate implement IoT within all their 30 units in 9 different countries. So the other value that we brought to the table was energy monitoring. Not energy monitoring per se, only the monitoring of energy where the units are consumed, but relating this energy with meaningful action. For example, for the press machine, the energy was compared with the output, number of strokes that was generated. So the end result was kilowatt per stroke. And in many cases where we could see that some of the machines that were using the motors, we could help them by analysis of the energy. We could also help them to downsize their motors so that they can efficiently utilize their energy monitoring. So the challenge right now we have with them is connecting multiple machines, connecting heterogeneous machines, and rising up to the occasion with respect to their expectation on the reporting layer as well. So talking about the report layer, I have a screenshot. This is something that iProd looks like, where you are looking at productivity, OEE, as well as condition-based monitoring of the solution. So I quickly run down through these dashboards. I have the application opened up. Let me go here. So this is something that the Daytonis iProd looks like. So the initial page is giving you the runtime history of what is happening in that particular line. So you're looking at grinding department or these set of grinding machines and what's happening. So the indications on red and green talks to you about this was the productive time versus the downtime. and also gives you a summary on what's happening with respect to production. So you have number of products produced based on the shift timings, what was the elapsed time versus comparative reasons on how much was my downtime versus productive time. So here again, tagging this to our topic, uncovering the hidden capacity. This is what your actual hidden capacity is. Unless it is unplanned downtime, there you can, you have something to take action on. And apart from this, we have standard reports which talks to you about daily production insight. So this gives a bird's eye view on what's happening on your manufacturing floor today, and you can compare this with the current OE, for example, how much capacity you are utilizing, what was the uptime, downtime versus how much you have produced, and also this is a demo instance. So if we would have put the plan, you would get the actual plan working in progress, as well as the plan versus actual and variance, and if there was a quality rejection, you would also get that. If I come down, you are getting comprehensive reports on OEE versus the productive time versus the downtime, and the PPC, primarily how much part I'm producing. Also mapping these with the operator. So we have come across organizations where they incentivize the operator based on good production, product that they are producing. So this is something that comes as a standard offering with respect to Daytonis. Apart from that, you can have many more reports where you can dig deeper on the production analysis with respect to each work center. So work center wise, what's happening, you get a bird's eye view on that. Also, top 5 losses for these particular work center, which were these. And let me go to the condition-based analysis. So this is where you are looking at the condition of the machine with respect to the key parameters that you are monitoring. So in this case, we are looking at bearing temperature, bearing pressure, etc. So you can map this with respect to the upper control limit and lower control limit, as well as do the 3 sigma or 6 sigma kind of processes, and then you can also monitor your CPK in terms of processes. It's always said that theoretically that if your machines are performing in the standard cycle with respect to the limits, then you are producing good parts. And that would be the conclusion of monitoring this. Apart from this, once you see that you see a substantial level of tweaks over here on the on these particular parameters, you can set seamlessly set alerts in this particular platform. And now there was a learning when we started building these standard reports and then offering with our customers. There always used to be some requirement with respect to building new reports, etc. So learning from this element, we thought about building something that can be seamlessly reusable, and you empower the business users to start building their reports on their own, so that they don't come back to us asking for more reports and eventually end up spending more money. So what we did over here is we evaluated some of the embedded tools and we finalized upon Power BI. So this particular integration is part of iProd with additional subscription, because we need to end up paying Microsoft for this. So here what you're looking at is the bird's eye view on the overall production, the different locations with your different plants, and you can dig deeper into doing analysis on different plants. So if I can dig deeper into, so I can get different analysis on the plant. So this gives you a seamless view on how your plant versus the work center is performing. So I dig 3 levels deeper for this particular plant. Also, I can get to know the plant quantity versus the rejection quantity. Now, I'll move to another report which also gives us a rejection analysis. So we have come across many customers who say that we need to have root cause analysis. So these root cause analysis will give you this picture about how where the rejection are being done primarily. So again, you have the ability to dig deeper into these reports and get to see how you can relate one particular data with another data. So you can have a bird's eye view again on the operator performance over here. So this is the operator performance with respect to a specific work center, and these are the number of parts produced, and you have the OE mapped across the across this particular work center, comparing with the operator. We are almost run out of time, so we just open this up for questions. Harish?
Sure. So we already have some questions coming in. Basically, the first question almost you kind of answered, but I'll still can clarify more. So the first question is, how do you start with the IoT implementation?
Oh, that's a very good question. In the past we have been attending a lot of events, participating in events, and much of the talks are revolving around what's the potential of IoT. We talk numbers provided by the large consulting companies as well as companies like Cisco, and we talk about billions of devices that are being connected versus trillions of dollars. But the reality is, actually get your hands dirty and get the plant going up and running. So typically when we look at such scenarios, is we initially talk with the customer, we get to know what their challenges are, and based on these challenges we start exploring more. So if I could take an example where you look at one particular plant and they have about 30 to 35 odd machines and 3 to 4 lines. And here we would look at the line which is most bothering or a bottleneck for them. And looking at that particular line, we would look at what are the challenges and how we can add value in a quick amount of time. So we would take that as an example and initially carry out a feasibility study. And this feasibility study would revolve around looking at the machines, how we can connect them, and looking at if there are any other parameters that we need to take, how we can take those parameters, and aggregation of the data, bringing the data together, and creating the value, and walking through the value chain with the customer, and creating the business benefits in a shorter span of time. So if I could, Harish, if I could talk about the implementation timeline. So the timeline based on the complexity for an example or a pilot would be anywhere from 3 weeks to 6 weeks max, based on complexity. And we walk this journey through our system integration partners. As we are a software product company, we rely upon our proven system integrators, where they help us in enabling our solutions. So the feasibility study is always conducted by a capable system integration partner who helps us strategize on the connectivity part, and after that we take over. I hope this answers.
Awesome. I mean, that was a follow-up question that had come up. Like, how do you kind of deliver the end solution to the end user? So rightly pointed out by you, we work with a lot of system integrators, and we are onboarding more and more partners. So basically, to give you a brief overview of the entire Altizon ecosystem, so Dayton, as it is, it's not a standalone platform. It has a very vibrant marketplace wherein we have a lot of business-specific or use case-specific apps developed directly by Altizon, as well as with our developer community that we have. So one of which you saw was iProd. A couple of others are ICBM, which helps you in condition-based monitoring, predictive analytics, and predictive maintenance. Then you have iEnergy, which helps you in energy monitoring. You have smart oil and gas, smart supply chain, and so on. So we have a very vibrant developer community which we engage with to develop business application-specific, business-specific web applications, as well as mobile applications. So in addition to this, we work with a lot of our ecosystem partners to provide a complete package solution from a single source to the end user. So it might involve global system integrators, or for the actual solution delivery, or hardware and semiconductor manufacturers for the hardware manufacturing part of it, or industry bodies, or certification, and being compatible with different protocols. So all in all, it's a growing ecosystem, and we are onboarding newer partners to grow it further and drive the Industry 4.0 journey together to help you uncover your hidden capacity for optimizing and substantially improving your throughput and quality. So it was a pleasure presenting this webinar to you today. I hope you found this helpful. Feel free to reach out to us or tweet us from your feedback, or mail us your feedback on sales@altizon.com, and we'll be happy to connect again with you. Thank you so much. You have a great rest of the day ahead.
Thank you.
Take care. Bye-bye.